Do you see the algebra? Do you see? Answer me.
Yes.
Okay. Now, do you see double cone?
Yes.
Okay. This is a three-dimension system, no? By the way, x-axis is the red one, y-axis the green, and z-axis the blue. 3D. And this is the conic. Double cone, double cone, double cone. So suppose que you intersection, double cone, and different plane. Let me show you. I put the red one plane, this crossed the double cone, and the intersection of the double cone is that figure. Okay. Supposed to see more clear, I delete the cone and delete the plane. And you see ellipse. So ellipse is the conic section that is formed by the intersection, the famous double cone, and one plane. And with a specific angle. I don't care that part. Pero es illustrate welcome from this. Es obvio que ellipse es a closed curve. Okay? This is the most important characteristic. I want to analyze in detail the different parameters que define the ellipse. Okay. Now, let me go to the parabola. Okay, again, we come back to double cone. No plane anymore. Another plane now. This plane. Boom. This is the plane. The intersection is this figure. Wow. And this figure is, let me delete the plane. No plane anymore. No cone anymore. No plane. And this is hyperbola. Hyperbola is formed by two separate curves. Okay, two separate curves. We discussing in detail in your moment, no? See, open over, downward, left, right. This is another topic que we discussing, pero it's basically is no closet, it's open, pero both branch. Hyperbola contain two branch. Con. And the last one is another plane, the last plane, green plane. And green plane intersecting the double cone and forming this intersection. Okay, this intersection is different. Let me delete the plane, let me delete the cone, and you see the parabola. The parabola is, you know, at least the shape is similar to the hyperbola, but only one branch. And we have different kind of parabola, no? Open over, downward, left, right. We discussing everything. And the most important now, okay, one you need to know is that we have three conic sections, ellipse, hyperbola, and parabola. Ellipse is the closed figure, hyperbola is two branch, and parabola only one. Okay, this is clear, the idea? Is it clear?
Clear.
Okay, super. Now, I want to come back again to the whiteboard. We discuss it in detail. Entonces, what about circle, professor? Bueno, circle is a particular case of the ellipse. Que you see que have a specific characteristic. And this is a equation that I want to write more clear after. No. You don't worry for this equation. We're discussing every day this equation. Okay, let's focus in the ellipse. Well, the ellipse have, look, a center. Similar to the circle, they have center. And we have two axes. The major axis is this segment, major, because of the big one. And the minor axis. And the minor is this. Okay. And the endpoint and the major axis called a vertex. This is a very, very similar word que we use in parabola, no? In quadratic equation, something vertex. So two vertex, vertex 1, vertex 2, vertex 2, vertex 1, doesn't matter what you call 1 and 2, and co-vertex in the minor axis, 1, 2. Okay, and so we have the major axis, the distance of the major axis this time, que es 2a. Normally it's the letter that we use to notate this. The a alone without 2 is the semi-major axis, this distance. And this distance is b. So this minor axis is 2b. And the semi is the half is b. Okay. And the focus is a super important point. You don't understand very well the importance now, but I want to explain in a few minutes. The distance here is the focal distance is c. So in the ellipse, we have three important parameters, A, B, C. Who is A? The semi-major axis. Who is B? The semi-minor axis. Who is C? The focal distance. Get the distance from the center to any focus. Okay, by the way, you have two focus. Okay? Okay? Do you understand this elementary idea? Good. So you have this elementary idea. I need to know, or I need to explain. Okay, we have two kinds of ellipses. You have two kinds of ellipses. I call this ellipse horizontal. Ellipse. Why horizontal? Because the major axis is coincident or parallel to the x-axis, que es the horizontal line, ¿no? Okay, entonces, this is vertical ellipse. Because the major axis is coincident or parallel to the y-axis. So basically, we have two kinds of the ellipse. Ellipse like that, or ellipse like that. Correct? Okay. Super. Now, definition. What comes from the ellipse? Well, ellipse, you see, one professor is the cross section between the double cone and the plane. Okay. But there are more formal definition. Look, let me show you in Desmos. Let me try. Switch into Desmos. Switching. There you go. Okay. Boom. Boom. Do you see Desmos? This is the animation to illustrate definition of them. Do you see or no?
No.
No. And other people say or no? Do you see or no? Nobody see?
No, I don't see.
No. Okay, let me try. I share the screen. Now? No?
Yes.
Okay, super. Okay, this is the animation que illustrate us definition of the ellipse. Entonces, en this ellipse, que by the way is horizontal ellipse, because the major axis is on the x-axis. And by the way, the semi-major axis is phi, que es the distance from the origin, the center, que es 0,0. In this case, I put easy. Look, I put equation for the ellipse here. Look, this is the equation. I want to explain it then, but no. I focus in the definition. And the semi-major axis is phi. The semi-minor axis is 3. And the distance focal is 4. Okay, those are matching perfectly because 5 squared is 25, 4 squared is 16, and 3 squared is 9. So the formula is a squared is equal to b squared plus c squared. It's the formula for ellipse. You need to remember. So as it's easy to remember because where's the big value in the list A? So A squared is equal to B squared plus C squared. Okay? And what's the definition? Well, the definition is the geometric place such that that segment, so you draw one segment for the focus. So you have two foci, in plural foci and singular is focus. You have two foci. One segment is in black color is from the focus 1, que es 4,0, to the specific point on the ellipse, no? And another segment is from negative 4,0, que is the other focus to the point on the ellipse. And the important thing I computed here, in the right hand side, you see the distance. The distance 1 represents the distance for the segment in the right part, and the distance on the left part is distance 2. And the sum of the distance 1 plus distance 2 is always equal 10 in this specific example. You see how distance 1 change in the animation, distance 2 change, however the sum doesn't change, it's 10. And what comes from this 10 is double, or not double, sino it's total major axis. The major axis of this list is 10, 5 plus 5 is equal to 10. This is the definition. Okay? It's the geometric place in which the distance from the foci to any point on the ellipse, the sum of this segment, is equal to A. 2A. And who is A? The semi-major axis. Do you understand the idea? Come on, guys. Answer me. Feedback. Do you understand the definition?
Yeah.
Okay, super. Okay, this is the definition. All right, let me explain one more thing to start the problem. No? Let me explain now eccentricity. Okay, because what is the relationship, what is the idea for the ellipse and circle, no? Ellipse and circle. So you have here, do you see again another script of Desmond, no?
Yes.
Yeah. Okay, let me try to explain. Eccentricity, que normally is called E, but E don't allow me to put in the decimals because E is a constant, mathematical constant. I put C1 or C2. It's the ratio between, the eccentricity is a number. Okay, vary from 0 to 1. And give me information how rounded or flat is my ellipse. For example, suppose que B, I decrease in B. Do you see the effect? The effect is my ellipse is a little bit more flat. But let me make a zoom to see more clear. And what happened with the position for the focus? Approach it to the vertex, right? And see, you put to like it was 0, B. I don't want to put 0 because disappear the ellipse. The eccentricity, que está number, is closer to 1. 0.98. One more, closer, 99. Almost 1. Do you see? So eccentricity is a parameter que give me information how flat or how rounded is our ellipse. Suppose, let me select one value. Suppose 5. And now I want to reduce A. Look, let me see the effect, guys. So now the major axis is decreasing. And you see now how the ellipse look like a circle. And what happened with the eccentricity parameter? Oh, I don't know. Eccentricity, remember, is C divided by A. If you put together A and B exactly the same, look at what happened with the distance. The focal distance is 0 and eccentricity is 0. Okay, so what is the conclusion? The conclusion is a circle is a particular case of the ellipse in which the eccentricity is 0. Yes, 0 because the focal distance is 0. So actually we have no two foci, no. We have only one que is coincident with the center of the circle. Make sense? Make sense? Make sense?
Yes. Yes.
Okay, super. And the eccentricity is equal 0 when it's a circle. And in the real life, the majority of the elixir, the eccentricity no es 0, no es 1, es intermediate value in between 0 and 1. Okay, we compare the example now. Okay, because I have another script que es the conic sections. Okay, conic sections. Okay, here I want to start example 1. Copy that, this example. I want to solve this example in the board. And after we come back to the Desmos to see the graph. Okay, I copy in the whiteboard. I delete everything in the whiteboard. Okay, example 1. Do you see whiteboard? Oh no. I suppose you see, no? Do you see?
Yes.
Yes.
Okay,
Yes.
super. Example 1. Always example 1 is elementary. X squared over 16 plus y squared over 9 equal 1. And by the way, this is the standard form. So the standard form, let me copy here. The equation for this elixir is x squared over a squared plus y squared over b squared equal 1. But not always is the same. Sometimes it's x squared over b squared plus y squared over a squared. So how do you know who is a and who is b? Well, a is always the bigger. A is the bigger. So basically, our example number 1 look like this format. Immediately you see, wow, a squared is 16, therefore a is 4. No plus or minus, because this is distant. So a represents the same major axis, is 4. And b squared is 9. Therefore, b is 3. And this elixir, what do you think about this elixir? Is horizontal elixir or vertical elixir? What do you think? Horizontal or vertical? Using intuition, common sense. No idea? Nobody?
Horizontal.
Absolutely. How do you know? What is the logic you use?
The A.
The A. Okay, A, que es the big, is associated with the X. Therefore, the major axis is parallel or coincident with the X axis. It's super easy. You see, wow, who is the bigger? 16 is the bigger, right? And the major axis is located in the X axis, horizontal. Okay, no secret. No secret. Okay. One more information we need. One more information we need. Okay, we need C. And why not eccentricity, no? Remember the formula for finding Z, so the formula is a squared is equal to b squared plus c squared. Be careful. This formula is valid for the elixir. In the hyperbola, when you study hyperbola, not today, we study the same parameter, A, B, C, but the interpretation is different and the formula is different. Now, don't confuse it. Every conic section has specific formulas. Okay, the vertex, see, I know. So I'm using my common sense, but I don't want to use the common sense. I want to use in Desmos. But well, okay. First of all, the center of this is 0,0. How do you know that? Because another hyperbola, another ellipse, sorry, the center is known in the origin. The format is different. It's x minus h squared over a squared plus y minus k squared over b squared equal. In this case, I don't see any h and any k. It's 0. Therefore, h comma k represent the center of the ellipse. Okay, in this specific elementary kindergarten example, it's 0,0. So I know that the major axis is 4. So from the center, you walking for 1, 2, 3, 4, 1, 2, 3, 4. So one vertex is in 4,0, another vertex is in negative 4,0. Okay, guys, I don't want to memorize stupid formulas. Some book give me the formula for any point. No. Using common sense. This is analytic geometry. So this is graphic. So you end it always graphically because the goal for this problem is do the graph of the ellipse. And A is 3 and B is 3, sorry. And B represent the semi-minor axis, 1, 2, 3. This point is the point 0,3. And this point is 0,3. Entonces our ellipse, I suppose que look like that. That's it, no? No, we have more information. We have the focus, and we have the eccentricity. Okay. This is the formula that we use every day for the ellipse. Okay. Now, the computer focus, the focal distance, SC. So C is equal square root A squared minus B squared. So and that formula is solved for C. Moving back to the other side, subtraction, square root of both sides. C is equal to square root A, que es 16, A squared is 16, minus B squared is 9, is radical 7. Okay, it's a rational number, no problem. You put a decimal approximation to have some idea, because the square root 7 for me is 2.646. Actually, the foci is located at the distance 2.6. It's close to 3, you know. Let me use in blue color. 1, 2, 3 here. Okay, and 1, 2, 3, 1, 2, 3, approximately close to 3. This point is the point 2,646,0, and this point is minus 2.646,0. Also, and eccentricity, remember, is denoted by the is the ratio between C divided by A. Can give me information how flat or how rounded is our ellipse. Entonces you divide, que es C, divided by A, que es 4. And you approximate in decimal, is 0.66. And remember, the eccentricity is always in between 0. Equal 0 is a circle. And 1 is a totally flat ellipse. This is circle, perfect circle. And this is no ellipse, it's totally a line, it's a flat. And this intermediate value, I suppose it's close to 1. To say my too flat, but look like flat. Approximate like that. Any question in this? This is the last time can do it by hand, that problem. After we're using this one. I want to show you how. I created a script. Okay, if you want, I send to you to do any graph of the conic section. Ellipse, parabola, hyperbola. Any question, any conceptual question that you don't understand? Clear? Okay, I switch into 2 decimals. Pero no these decimals. No the decimals. That one. Okay, this is a script I want to send by email. Okay. You select example 1. Look here. Boom. And this is how.
Professor, where's the whiteboard?
Okay. Let me show again. Switching to this. Now, you see? You see?
Yes.
Yes. Okay, super. I put equation, that's it. However, in order to find the point, I create the script. And we should put A equal 4. Look in the slider. B is equal to 3. Don't worry for H. H and comma K is 0,0 and P is the parabola. I don't want to discuss it today. I suppose. No, not today. Today is elixir only. So now the center is 0,0, nice. And A and B is 4 and 3. We compute before in the whiteboard. Okay, now you classify like a horizontal elixir, right? It's a horizontal, no? And you click here. Boom! And give me all information I need. The vertex 4,0, negative 4,0. The co-vertex 0,3, 0,3. Sometimes call it co-vertex, sometimes call it endpoint of the minor axis. It's the same. And the foci is located in radical 7,0, que in decimal is 2.646,0 and negative 2.646,0 and the center is 0,0. Wow, fantastic. And you see in different color, a minor axis in red color, a major axis in the purple color, and the focal distance no color. Okay, it's not important. Do you understand very well?
Yeah.
Do you understand very well? Good? Was good? Clear?
Yes.
Come on,
Yes.
guys. Okay, now I want to complicate more and more. This is now super basic, super easy. Okay, let's move on to the whiteboard now. Okay. Erase. Example 2 now. Example 2 say 25 x squared plus 9 y squared equal 225. Don't expect okay, in the test I give you the nice conic section. No. I give in different way and you manipulate in order to put in a standard. The standard is when the right hand side is 1. Okay, this is a standard. Maybe x squared over a squared plus y squared over b squared equal on the, remember that there are two different ways, no? Or x squared over b squared plus y squared over a squared equal 1. So I need to manipulate this equation in order to express it that way. And you determine who is A and who is B. Remember, A is the bigger. Okay? But it's easy. You divide the entire equation by 225. And the story. You divide this equation divided by 225. 225. 225. 225. I guarantee you have 1 in the right hand side. Who is 225 divided by 9? Put in the calculator. 225 divided by 9 is 25. We have y squared over 25 plus Now 225 divided by 25. Well, it's all because 9, no? It's all because 9. It's x squared over 9. Oh, nice. This is my equation in the standard. Okay, always we divide by this because I need to guarantee one on the right hand side. This is a standard. Entonces, who is A, who is B? It's the challenge. Who is A and who is B? What do you think? What is A, what is B? Let me compare. Basically, it's x squared over a squared plus y squared over b squared equal 1, or another possibility, x squared over b squared plus y squared over b a squared equal 1. And you keep in mind this equation and you compare with our specific example, no? And you identification, who is a squared, who is b squared? Who is a squared? And who is b squared? Answer me.
A squared is 25.
25. Very well. And b squared is 9. And a is a square root of 5. And a square root 9 is 3. Okay, super. Entonces now, my ellipse is vertical ellipse or horizontal? It's like that or it's like that? What do you think? Horizontal or vertical?
Horizontal.
No, because the big value, what is the big? 5 and 3. What is the big? F5, no? It's associated with the Y. Do you see or no? Means,
Yes.
oh, entonces es vertical, right? When I finish the word, my graph look like that. No like that. Okay? It's clear or confusing? Come on, feedback.
It's clear.
Excellent.
Clear.
Now, I finish. I need to find the vertex. Well, by the way, the center of this ellipse is located at 0,0, no? So the center is at 0,0 because I don't see any H and any K here, no. Entonces the vertex is orientate. The vertex is orientate in the same of the major axis. So I know that my ellipse look like that. Approximately, roughly sketch. After we're doing super fantastic in Desmos. And this distance is A, and this distance is B. Make sense? Now that point is the point 0,5, and that point is 0,-5. And that point is 3,0, and that point is -3,0. I'm doing well or no? Well or no?
Yeah.
Okay, and see, here's the focus, the distance, focal distance. Okay, by the way, the focal distance always is located on the major axis. Okay, is square root? Sure. Square root a squared is 25 minus 9. Okay, 16. Why 4? Ah, easy. The focus or focus is located at the point 0,4 and 0,-4. Super good. Is confusing that part or is clear? And the eccentricity is C divided by A. Always, it's the formula. Who is C4? Who is A5? And decimal is 0.8. I suppose that this elixir is a little bit flat, like that. Not like the other. Remember, the other was horizontal, pero the centricity was 0.66, and now the centricity is 0.8. Pero es vertical, pero es flat. Make sense? Easy or complicated?
It's okay.
It's okay. But let's do in Desmo, no? Because I want to do the word in the piece of paper, but to double checking my words, see everything is good, no? You are using this one. Let me try. Yeah. This one. Okay, that was example 1. It's a history. Now I'm moving on to example 2. In the example 2, we have, oh, I copy exactly the same, not necessarily you copying standard. You copy exactly it's given in the problem, no? Do you see very well or no, guys? Do you see very well or no? Now let me delete that part. No. Okay, do you see the example 2? Do you see what decimal or no?
Yeah.
Okay.
Yeah, we see it.
Example 2 is 25x squared plus 9y squared equal to 225. Okay, let's do it. Boom. Oh, it's expecting. It's vertical elixir. Yes or no? It's vertical. Now A is 5. Because I set up in the slider here. Okay, prepare for this. Okay, 5. No 5. 5. B is 3, no? B is 3. Okay. And H and K is 0, 0. Okay. And you categorize what kind of elixir is vertical or horizontal? Because the equation is different and the procedure and the algorithm is different. It's vertical, right? Vertical elixir or horizontal?
Vertical.
Vertical. So you classify vertical, and this is the famous one. Look at the point, look at the point. Let me summarize quickly. Center, 0,0. Major axis or vertex is 0,5 and 0,5. Foci is 0,4 and 0,4. And the endpoint of the minor axis or co-vertex, the name you want to call it. I prefer endpoint in the minor, is 3,0 and negative 3,0. End the story, I finished. Any questions? Clear or confusing? Super.
It's clear.
Eso, bueno. Let's move on to the whiteboard. Okay. I want to complicate more this. It's obvious. Just too easy. Example 3. In the example 3, we have this. X minus 3 squared divided by 16 plus y plus 2 squared equal 25 equal 1. Okay, this is the question that's given of the elixirs.
Professor, we don't see the whiteboard.
Sorry. Now, mister, you see or no? You see?
Yes.
Okay. In this case, the new thing that brings me this problem is that the center is no 0, 0. The center is at the point, I have no idea, I lost x minus h squared over a squared or b squared, I don't know, plus b squared y minus k squared equal 1. No, you have this possibility, this possibility. X minus h, so always h is associated with x. Maybe it's b squared here plus y minus k squared over a squared equal. So we have two possibilities. My central idea now is who is h and who is k. So I need to find the component of the coordinate of the center. The center is located at the point h comma k. Who is h and who is k? Who is h? Who is h? Please compare this equation and the given equation. No? Who is h? H is -3 or +3? Okay, guys, are you there? No idea. What happened? Any answer? Or at least you say, Professor, I don't know.
Yeah, I'm not sure.
Not sure, no? But you have some idea. Huh?
A little bit.
Well, give me your idea. You are a student, no? So you make a mistake, no problem. You make a mistake in the test, yes, you have problem. But here, no? Nobody have idea. What is H and what is K? Compare the equations. Suppose the equation get much better matching. What happened, guys? And you advanced student, no? You are not kindergarten students. It's this equation. We got the big number get 25 as associated with the y, no? But this is another problem. The problem is who is h, who is k. Well, h is always the number associated with the motion, the shift, and the x, get 3. But it's very, very tricky because it's 3 positive. Because my equation considers negative. And when you compare, it's obvious that h is positive 3. However, k no. K is negative 2. Similar to the Color algebra, when you find the center of the circle, it's the same number that you have in the parentheses, but the opposite sign. And the equation is opposite sign to the point. Make sense? Oh. Make sense or no? Come on, guys, what happened?
Yeah, it makes sense.
Yes.
Okay. Okay, what about A and K? A and B, sorry. Who is A, who is B? And who is C? Who is A? Or at least who is A squared? B squared? Who is A squared? Come on.
25.
Excellent. Therefore, A is 5. This is square root. And B is the another guy. You take A always is the bigger value, is the major axis. And this is 16 is 4. Okay? And what about C? Well, the formula is C squared. Well, C is square root. A squared minus B squared. So square root. A squared get 25 minus 16 is 9. And square root 9 is 3. So this is focal distance. That's from the center, que the center is 3, -2. You're moving, but in this, so I know that this ellipse, the center is located at the point 1, 2, 3, 1, 2, -2. This is the center. And this ellipse is vertical ellipse or horizontal? What do you expect? Vertical or horizontal?
Vertical.
Exactly, very well. Because 25 is associated with the y, que is the major. And the major axis is parallel to the y-axis. To find the distance is super easy from the center. you moving 5 units over and to get the vertex 1. So this distance F5. This distance F5. And to find another vertex, you subtracting 5. To find the endpoint is in that direction is addition 4 and subtracting 4 from this point. And the focal distance is subtracting 3, addition 3, sorry, from the center. The reference is the center, because so far in the other problem is 0,0, but in this case, no 0,0. Is 3 units upward and 3 units downward, and you get the focal, the position for the fossil. Okay, let's do it in decimals to see more clear. Because this is elementary addition, subtraction. This is upward addition, si es downward subtraction, si es to the right es addition, si es to the left es subtraction. This is elementary arithmetic, ¿no? Okay, entonces now let's see. Entonces the conclusion is our elixir, the center is located at the point 3, -2, and also is vertical elixir. Okay, I got it. Okay, let me go to the decimals. This one. Okay, that's what example 2. Okay, finish. Okay, however, I delete that. Okay, now in our example 3, AF5 and BF4. But H is 3. You can move in the slider or you plug in here. And D and K is -2. You using the keyboard and you put -2. -2. Okay, good. Okay, this is my example 3, no? Example 3, elixir. Boom, wow. Do you see green color? Elixir. But center is located at the point 3, 2, 3, -2 here, approximately here. In the center. Okay, let me try. So basically I got classified like a vertical, no? Vertical. Oh. Okay, something is weird. Okay, something happened. Okay, something is weird. Okay. It's the center. The major axis make a mistake. I need to fix that. Okay. It's a vertex, and a vertex, fossil, endpoint for the minor axis, and the only mistake was I need to fix the equation for the major axis. It's a little bit complicated. Do you see that? Yes or no?
Yes.
I forgot the centricity. I forgot the computer. So basically, let me go back to the whiteboard. I summarize. Okay. Our vertex in plural is located at the point 3,3, no? And 3, -5. Because B is 4, no? And the fossil is at the point 3,1 and 3, sorry, 3, -5. And this is 7 because of 4. So say 7, -7. Here is -7. Well, and the centricity, one of the endpoint for the minor axis would be endpoints of minor axis is the point que is in that direction is -1, -2 and 7, -2. And the eccentricity is C divided by A. C is 3 and A is 5. And this is my 0.6. Okay, a little bit flat, not too much, but it's a little bit flat. Let me double checking. It's -2. The endpoint, yeah, it's -2, yeah. Let me check it with the decimals, see I make a mistake or not. If 7, -2, nice. -1, -2, nice. 3,3, nice. 3,7, nice. And 3,1, and 3,5, nice. Everything is okay. Do you understand very well where I come from that point or no? We are lost. Now, from the center, for example, let's do a vertex. The center is located at the point. Do you understand where I come from very well or no? Because I don't want to waste the time, no? The center is located in 3, -2. 3, -2. Is our center. But A is 5, no? A is 5. Entonces, that point que es 3, -2, you move 5 units over. Entonces, when you move 5 over, you increasing the y component. So at this point is 3, something because it stays the same. We don't move horizontal, you move vertical. Plus 5 is -2, plus 5 is +3. Likewise, when you move down, you're decreasing, you're subtracting. Entonces, down, that point is 3, -2 minus 5 and -7. Make sense? Make sense?
Yeah.
It's logical, no? It's easy, no? To verify that. So I don't want formula. No. And also I will send to you my script in GeoGebra and you can use it. No? This is not perfect. Just do it for me, no? I'm teacher, no professional. Entonces now sometimes making some mistake. Pero bueno, you can compute it by hand if you want to verify. At least it's a help. Got it? Example 3 is okay or no? Confusing?
Yes, please.
That's true. Okay, let's move on to example 4. In example 4, we have different. Totally horrible. Okay, 3x squared plus 7y squared plus 6x minus 28y plus 10 equal to 0. Wow, this is completely different. This is very, very similar to the thing we're doing in college algebra. In college algebra, sometimes when you study circle, no ellipse, you complete the square, no? To make factorization. In this case, similar, you complete the square. But how do you know this ellipse and no circle? Well, in the circle, this coefficient and this coefficient must be the same, 3377. So it's different as ellipse and it's plus, because sometimes it's minus, so it's hyperbola. So we study hyperbola another day. This is basically ellipse, but this ellipse is translated shift horizontal and shift vertical. How do you know the shift? By completing the square. But the organization by completing the square is you grouping the x and the x and the y and the y. And this number, just a number you move to the right hand side. So you group it 3, 3, 3, 3. 3, 3. You group it x squared. And 6x is 2x. Do you understand this? The thing I am doing? Because 3 and 6 is common factor. Is there common factor que es 3? I factor out 3, ¿no? Plus something. Que es the magic number que complete the square. Plus, likewise, I do in the y part, it's 7. Y squared minus 4. Y plus box. And in the right hand side, I have minus 10. Que do not participate in the game. Plus 2 boxes. And these 2 boxes is a magic number que complete the square. Everyone follow me in this organization? Actually, in the test, you see problem like that. But you put elementary, at least, no? Okay, you see using your eyes, this is A, this is B. No. You need to manipulate. So what is the magic number que complete the first square? It's 1, no? Because 2 divided by 2 is 1, and the square is 1. And this 1 is this. And likewise here 4, I don't care the sign is not important. Divided by 2 squared. 4 divided by 2 is 2, 2 squared is 4. It's a coincidence que es 4. No surprise. It's logical. Okay? Oof. Now the factorization is 3. When you complete the square, you guarantee that this trinomial is perfect square. And the factorization is no 2 binomial, it's only 1, que es x plus 1 squared. 2 in brother. Plus 7, in this case minus, so y minus 2 squared, equal, I forgot that part. I forgot here, well, the number here and the number here. The number here, be careful, because the number here is not exactly coincident with this. Remember, we have factor, you factor out. So this actually, this one que you put inside the parentheses actually is 3, because 3 times 1 is 3. This number is 3. And this is 4 times 7 is 20, 28. Entonces 28 plus 3 is 31, minus 10 is 21. Pero positive 21, right? Do you follow me so far? This is complicated for you or it's clear?
No, it's clear.
It's clear. Now almost we finish. Now remember standard form of the equation for the elixir. Right hand side should be 1. So you divide by 21 here, 21 here, and 21 here. 21 divided by 3 is 7. So actually it's x plus 1 squared over 7. Nice. Plus y minus 2 squared equal 3, because 21 divided by 7 is 3, no? And it's 1. Wow, fantastic. This is my standard. This equation is equivalent 100% to the original ugly. Okay, nobody know, nobody understand. And magically, you apply complete square 2 times for the x part and the y part. Now, definition, center. What is the center of this elixir? Please help me. Any help?
-1, 2.
Excellent. Very good. -1, 2. Who are you, Amore, no? You are Amores, Mr. Amores.
No, Anthony.
Anthony. Anthony, what? Anthony, Exposito. Source. Okay. Very good. This is center, guys. Remember, it's exactly the same value that you display here, but opposite side. And this is, who is A and who is B? This is a little bit weird. A or A squared is 7, yes or no? And B squared is 3. You see? Therefore, alone is square root 7. And square root 7 is irrational number, get decimal approximation is 2.645. And B is radical 3, que es approximately 1.732. Okay, you round to the 3 decimal place because you are doing exactly the same with decimals. Decimal truncated in 3 decimal place. Super, super. But I need C, the fuzzy. Okay, and C is, remember the formula is square root 7. Okay, say square minus B squared is 3, 4. Go to 42. Nice. At least one number is nice.